Hey everyone, so the audio did not record on my first video, so I'm going to try to do this one a little quicker. So what I'm going to show you guys is the process for creating a confidence interval for your sample means. So I'm going to write the formula out here. So what it starts with is taking the sample mean itself. So you ran a random sample, and maybe you collected the average height or the average salary or the average age of certain players. For me, I calculated the average salary. So my X bar is going to be the average salary that I got in my sample. That's going to be the center of my confidence interval. But because I know that there is sampling error every time I take a sample, I'm not guaranteed to get the right answer, but I'm going to get somewhere in a bell curve. So what I need to do is I need to add and subtract a margin of error. So for the confidence interval, you start at your sample mean, and we're going to add and subtract the margin of error. So the margin of error is calculated as finding the proper t-statistic and then multiplying that by the standard deviation of your sample divided by the square root of the sample size. So in the standard deviation formula for sampling distributions, the sigma up here is typically the standard deviation for the population, but because we do not know the standard deviation of the population, we are going to estimate it by using the standard deviation of our sample. Um, and yeah, so we're going to use the standard deviation of our sample for sigma. Okay, so for me, in my case, I took a sample of 55 Major League Baseball players, and I calculated using the spreadsheet that their average salary was $3,075,000. You can see the formula up here that I used for average. So equals average, and then just select all of the numbers, and the computer will tell you the average. Okay, so that gives us X bar is going to be 3,075,402. I'm gonna find sigma next, the standard deviation of the sample. I'm gonna need that. And then what I did is if you look at the green circle up at the top, it's now showing the formula for standard deviation if you're doing this in a spreadsheet. So just type in equals STDEV and then select all of the numbers that you collected, and it will give you the standard deviation of your sample. For me, the standard deviation was actually bigger than the average. The standard deviation was 5,124,139. Okay, my sample size N, that's how many individuals I had in my random sample. For me, that's 55. And for the T statistic, what we have to do is we have to reference this chart to figure out what is the proper T statistic based on our desired level of confidence and our degrees of freedom. So the degrees of freedom is just the sample size minus one. So for me, I had a sample of 55. So I would use 54 degrees of freedom. In this table, it only gives me 50. So I'm just going to use 50 as the best estimates. So for your degrees of freedom, that's one of the numbers you have to kind of reference in this table. It's always your sample size minus one. So if you took a sample of 30, you would use 29 degrees of freedom. And then I just need to match that up. So at the top here, we have the different significance levels. And if I want to do a 95% confidence level, that's going to be the highlighted green column here. This is for 95%. You can always just take away this number from 100. So this one is zero point 0.1, so this will give you 90% because you're taking away 10%. This is 0.15, so this will be 85%. This one is zero point 0.2, so this will be for an 80% confidence interval. And another, for example, you could do this one, and that would be 99% confidence. So depending on your confidence level, you'll choose a different column. For me right now, I'm going to do 95, so I'm going to use the green column. Let me erase here. So I'm going to use the green column, and I'm going to match it up with my degrees of freedom. And my degrees of freedom, I'm going to round that to 50. So it looks like the T statistic I'm going to use is 1.676. So I'm going to use 1.676 for my T statistic. All right. So let's go back to it. Okay. So now let me write that down. So my T statistic, because I had a degrees of freedom of roughly 50 and I wanted 95% confidence, I believe it was 1.676. That's going to be my T statistic here. So if I'm now filling in the equation to create my confidence interval, I am going to start with my sample mean X bar. That is 3,075,402. And then plus or minus. So this is my sample mean. I am going to add or subtract the margin of error. So whatever you get here for your T statistic multiplied by the sample standard deviation divided by the square root of the sample size, That altogether is the margin of error. So we're going to add that to the sample mean. We're also going to subtract it from the sample mean. So let's fill in those numbers. So for T, we got 1.676 using the table, and that's based on our degrees of freedom and our confidence level. And then sigma, we got as 5,124,139. And we're going to divide that by square root of my sample size. My sample was 55, so I'll take that square root of 55. Okay, so let me do some of this math for you guys in the spreadsheet. So I'm just going to do these, I'm just going to try to do this in the spreadsheet to kind of show you guys how you might do it. So let's just find the square root of 55 first. Square root of 55, square root of 55. Okay, that comes out to, so this is the square root of 55 is this. So I am going to figure out what is 5,124,139 divided by the square root of 55. So divided by this number here. So that gives me 690,000, something like that. This needs to get multiplied by 1.676. So let's do 1.676 multiplied by that number there. So this is my margin of error. It comes out to 115, or sorry, 1,158,013. So this is the amount I need to add or subtract to my sample mean in order to create my confidence interval. So what I'm going to do is I'm going to start with my upper bound here. I'm going to take my sample mean, so 3,075,000, and I'm going to add my margin of error here. That's going to give me the upper bound of my confidence interval. And then for the lower bound, I will take my sample mean and subtract the margin of error. That will give me the lower bound of my confidence interval. So I've taken my sample average, the average that I got in my sample. I have added the margin of error. I have subtracted the margin of error, and this gives me my confidence interval. Oh, darn it. Sorry, I did not mean to take that away. Okay, well, so that gives me my confidence interval. So here, this is the confidence interval. On the high side, I have 4.2 million roughly, and on the low side, I have 1.9 million roughly. So what I can say is that assuming I took a good random sample, I am 95% confident that the true average salary for MLB players is somewhere between 1.9 million and 4.2 million. So that is how you can interpret that confidence interval. So I am 95% confident that the true average salary is somewhere in this range between 4.2, 4,233,000 and then 1,917,000. Um, for different confidence levels, you'll have a different T statistic, and then for different sample sizes, you'll have a different T statistic. Okay, so hopefully this helps. Thank you guys very much, and good luck finishing up the final project. All right, thank you.